Well, hello everyone. This is another session in the J Champions Conference. My name is Barry Bird. You can see that in the lower left corner, right corner. I don't know. I'm confused. Andrew Greenstein, who is supposed to give a talk right now, is unfortunately taken with strep throat. We wish him well. Very fortunately, thankfully, Oliver Druckbaum has offered to fill in at the very last minute, and he's here. He's a senior principal software engineer at Pivotal, a Java champion, of course, and member of the JPA 2.1 expert group. He's going to talk to us about Spring Modulith, Spring for the architecturally curious developer. And I'm curious to find out what this is about. So,
Good
Ollie,
evening. Thanks for the intro, Barry.
go right ahead.
Um, I've just mentioned it, like we've been talking a minute before we started here, that it's been, I think, the most short notice talk that I'm about to give, but I've done this before, fortunately. Welcome everybody to this great this year's episode of the J Champions Conference. Barry, can everyone see my screen, or do I have to do anything for that?
We don't see your screen yet.
It's shared, so I guess you just have to
Oh, I
pick
got
the
it.
right link.
Okay, here we go.
All good, no worries. As Barry mentioned, I'm working for a company called VMware, previously Pivotal. We've been bought by VMware quite some time ago. I've been a member of the Spring team for over a decade and have worked on the data projects most of the time. Now I've moved on into that area of, let's say, architecturally related work within the Spring Framework team. So we're kind of exploring or look at the software systems that customers build and what architectural challenges they solve. And the last couple of years been dominated by the move towards microservices, but we also see a couple of teams paddling back on that a bit and trying to solve the problems that they were previously maybe trying to solve with microservices in a slightly more monolithic arrangement. That doesn't mean that they only write a single piece of software and deploy that, but let's say a handful, and then still try to maintain a bit of structure in within those individual applications, right? And we're exploring basically possibilities to support developers with that effort, and that's basically the work I'm going to show you in a bit with a bit of theoretical background and then a lot of demos going forward. So that's basically the context. A lot of the stuff that you will see here will also appear in written form in a book that's coming later this year called Monolithic Applications with Spring. So there's I think the QR code basically brings you to the LeanPub page of the book. So watch this space basically, right, for more details. All right. So what we're going to have a look at, or an example domain that I basically picked, is some excerpt of an e-commerce domain that basically deals with, we just need two or a couple of different logical functional modules of your overall system, right? So we start with, we have some orders, because you probably can relate to that. Basically, it's similar to an Amazon website or any e-commerce software system would basically just work as a comparison here. That basically deals with orders, and the orders have line items referring to, let's say, products or what have you, right? So we want to order, let's say, 5 TVs or something like that. And then the second part of our domain is the inventory, meaning it keeps track of the stock of the things, of the goods we want to sell, right? So the idea now being that, for example, if we place an order ordering these 5 TVs, then there's, by some means, we kind of have to update the inventory for that particular TV and basically reduce the stock by 5 items, right? So very, very simple, fundamental a business problem, and this stuff could be the outcome of an event storming session, of some kind of modeling of your domain, and you basically explored your domains, and you decided, okay, we need these 2 logical parts in our application. And if you were building microservices systems, you would go ahead and now basically create your one application for the orders and one application for the inventory, and then decide for some technical arrangement how they interact with each other, either calling each other via HTTP or sending messages around. But if we decide we want to keep those in a single application, then the question comes up, like, how would we express these modules, and how would we basically establish the interaction, right, for that particular business use case. So coming out of this modeling session and like putting a lot of post-its on a whiteboard, this is kind of, I mean, we've achieved a bit already, right? We've understood the domain, and now we're back to our desktop computers and want to basically build this stuff, right? There's a bit a constraint to this statement here. It's like, if you're working at Miro, then of course post-its are running in production. But if you're not working in Miro, you're going to be back at your desk. Probably if you're building a Spring application, come to start.spring.io, create an application. You basically, as you can see on the right, you would choose basically, in this case, the web stack, a JPA stack, and include the Spring Boot DevTools for a smoother development experience. And that would give you a project skeleton that looks something like this, right? We don't have to go through this in detail. It's basically just an empty Spring Boot application, and you get your dependencies declared, either a POM file or Gradle build file set up, and this primary application class here that would basically just run the application, right? So that's great and fine, but now what? That doesn't really help us with our domain, right? Or with our domain structure and basically getting that into the project. So what we could do is, and that's probably a pattern that we see like people use a lot, is to just go ahead and in our very project go ahead and basically create some packages, right? The base package for our project. This is where our application class lives in, and then you usually find some kind of technical structure. In this case, you see a layered architecture approach here, right, with the domain being on the side, and then web UI, some business logic in the services package or service package, and probably persistence, anything related to data access, right? And this is quite a common phenomenon, basically, that people or that teams structure their applications in a technical way, right? And there's like, even got to this point where at some point I was kind of claiming, when I was visiting a customer, looking at it at their code base in Stuttgart back then, you could basically find out like what the architect, what book the architect read most recently, because whatever kind of dash architecture style you're kind of you fancy these days, is this onion architecture or hexagonal architecture, you usually this stuff gets translated one-to-one into the code base. So you find ports and adapters and these kinds of things as packages. Unfortunately, this is a problem, right? And we get to the point why this is and how we can do better, and how in the end Spring helps us with, or a particular Spring project can actually help us with that, right? If we structure, or what's happening here is, whenever you structure your project based on a technical on a technical grouping, you create a structure that looks like this, right? So you're merely grouping elements of your code base by technical aspect. So all Spring controllers go here, all services go here, all repositories go here. The problem with that is the controllers amongst themselves don't really have to do anything to do with each other, right? They don't depend on each other, which means that a package, which is actually a unit of cohesion, it cannot really be cohesive. It's just organizing and grouping stuff and not creating any encapsulation, because of course all the important dependencies between the individual components in the system cross the package boundaries, right? So that basically results in low cohesion of the system and high coupling between the packages. So it doesn't even help us organize the domains really, right? So there's been a blog post by Dan North recently. There's been a bit of a backstory here. He's making up, or he came up with with an alternative acronym or alternative approach to the solid principles. He named it Cupid for joyful coding. And the D in Cupid, there's like 4 other different initials, of course, but the D in Cupid is for domain-based structure and domain-based boundaries. So he argues that to be able to change a software system easily, you have to be able to look at the code base and get a feel for the domain, right? You have to, I want to change something with the orders. So I have to find all the code that's related to orders, right? So instead of using a technical division mechanism on the top level, we basically suggest to start with a functional one. So in this case, okay, let's just literally translate the logical modules that we found into packages. That's what I was trying to say immediately, right? So let's start with that, and then let's say within that package we could still have our controller or service or repository, but at the same time, whether we actually need sub packages for that, we will see, right? We start simple. We just like start with a simple package, and that kind of leads to like an immediately better structured application, because the components residing within each package have a natural cohesion, right? The controller depends on the service depends on the repository. Whatever you do internally, usually the functional packages allow us to basically group more cohesive components within each other, right? So we basically, what that means is that we also reduce the number of dependencies that we get across the package or the packages, and that will help us to govern or find out about potential problems like cyclic dependencies between functional units and what have you, right? Right. So that's kind of that's just a package structure that we kind of start with. What does Spring have to do with this? Spring as a framework has like, or the stereotype annotations in which or with which you demarcate or basically declare your code to be a Spring component are also aligned with the technical aspects of an application. You have an add controller annotation, you have an add service annotation, and there's an add repository annotation. There's even like the Spring Data repository abstraction, right? The reason for that is that it's usually technical concerns that Spring is interested in, right? WebMVC works with the mappings defined in a controller method. Transactions are usually applied on the service layer level. Exception translation for persistence exceptions is applied to the data access level. So that's kind of the stuff that Spring Framework is interested in, right? The aspect, basically. The same goes for the testing support in Spring Boot, right? You have support for testing the data access layer only. You have support for testing the web layer only. But what I was just suggesting is to rather focus on the verticals, right? The business verticals. And as I said, we can basically assign code to the different layers by using these annotations. But at the same time, we can, if you follow the package suggestion that I just described, you kind of assign code to be part of the logical order module, the order package, what have you, but just by placing the code into those packages. So if we were able to identify those logical units, right? So kind of find out what constitutes an order module, right? Then we could do similar things that we do to the layers to the functional units of our application, right? We could verify that like we do not have or we do not establish cyclic dependencies between the order module and the inventory module, right? We all know that like on the layer level or basically for layers, you shouldn't have cyclic dependencies, because that basically reduces or increases the risk of a change in some place breaking something in the other, right? Only if you have a directed graph between the layers, then you'll be able to change, let's say, the web layer without breaking anything in the service layer. The same applies to the function units. It's even more important there, because we don't want, like, say, have team one working on the orders, the other one working on the inventory, and they constantly breaking each other's code, right? So a directed dependency graph for the functional unit is just as important, if not even more important. And we could verify this, right? There's tools like ArcUnit that would go ahead and basically allow you to describe your intended architecture, and then you can verify whether that your code actually fulfills that with these kind of dependencies. There is support for testing individual layers. I mentioned that in Spring Boot. What if we were able to actually run only the order module? Let me just stay with that term, with the order module of our Spring Boot application, right? If we could just bootstrap a vertical slice of our application during tests so that we could basically isolate it from all the other stuff that's going on, right? So if you're using add Spring Boot test, for example, you usually bootstrap the entire application. And if some other team's code within the application breaks that bootstrap, then your tests will fail as well. And we could basically avoid that. We could create documentation, like which modules do exist, how do they actually depend on each other, yeah, and like what establishes such a module, like what are the publicly available types versus the ones that are internal, what are the configuration properties per module, yeah, and we could also, that's something that's probably a bit like more advanced, we could also or let me phrase it the other way. If we were to build this application as a set of microservices, you would at some point want to find out about, okay, I trigger this order to be completed, and that issues the update of the inventory in another system. And to be able to actually observe that, you use stuff like Micrometer and Zipkin to basically trace the request through the entire system. If we can do this with multiple systems, why shouldn't we be able to do the very same thing if we build it just as a monolithic application, if we find the boundaries of our functional parts in the application? So that's been a lot of stuff already. And to help you with all of this, organizing your code accordingly and basically benefiting from you organizing your code this way, there's a helper we actually built. It's called Spring Monolith. It's been an experimental project, been introduced in, I think, end of last year in its first version. There's going to be a release, I think, tomorrow or early next week, a new one. That will help you with that. And to show you that, I have prepared a bit of sample code. That's available in the GitHub repo under Arc Evidence Spring. It's a repo that is basically a commit per step. So I guess we're going to skip step 2 today, but you can basically check out the individual steps and basically see what has changed from step to step. But the primary run through that we're going to do now is also described in the README here, right? So that you can basically redo the stuff that we were just doing. So unless there have been any questions already, Barry?
So we do have a question.
Go ahead.
How does this modularization differ from JDK 9 modules?
That's a good question. There's like a couple of different aspects to that. The primary one is that JDK 9 modules require you to have each module as an individual jar, right? So you would be kind of not even incentivized, but you can't actually build individual logical modules in a single build unit. And if you, as you will see in the demo, if you just like, okay, want to structure your Spring Boot application, your single jar Spring Boot application in a certain way, then you of course could go ahead and use build modules like Maven or Gradle build modules, and then use the JDK module system just fine. But that might just be overkill, right? For the time being, because you start small, you have like 1, 2, 3, 4, 5 different modules. Another aspect of this is that as you will see in the test support, we can dynamically decide which parts of the application module graph we will include in the test run, and that's slightly like more complicated and technical with JDK modules. Be reminded that the JDK module system was built to modularize the JDK, not necessarily as a general purpose application module system, right? All right. So with that, let's jump over to the sample application that I've brought you with. That you see that we have the inventory and the order packages here. So I basically structured the application like I suggested already. And you see that like all the components in there. So there's a configuration properties class that's basically just a Spring Boot feature to bind properties from the application.properties file to, let's say, example.inventory.stock_threshold, Spring configuration properties. Nothing fancy here. I want to focus on the relationships that we could establish between the different functional units, right? That's my primary focus here. For one, there is a relationship that if you have a look at the order management, that's a service, and it depends on an internal component, so to something within the module, and also reaches across the aisle basically into the other modules. So it's using a service from the inventory module, right? And it's already implementing kind of. It's not really implementing anything really here, but it's kind of like showing you the structure, right? We want to complete the order, so we update the inventory and then save the stock. It's all like demoware here. Bear with me. So for now, it's just okay. We use a publicly exposed service by the inventory, right? That doesn't actually prevent us from the order management actually referring to the private. If we go here, inventory repository, so we could we can actually refer to some internal component of the inventory, right? So what we're currently not even doing is to decide we do not actively decide what's part of the public API here and what is not, right? Like for the inventory module, and we could actually go ahead by just using Java modifiers, right? Like the visibility modifiers. That would immediately render this code basically invalid because the compiler now helps us to avoid this illegal reference to some internal component, right? And if it's the cheapest thing that we can do, and if it does the trick, then we of course do that, right? So if you can stay with, let's say, a single package per module arrangement, that's just fine, right? We can do the same thing here for the order repository, and basically hide everything that's not of the business to another module by using these modifiers. Now, let me go back here. What if, let's say, the arrangement of our, let's say, logical module here, our application module, is slightly more complex? So what if we have internal like sub packages basically, and those kind of considered internal? So if we, let's say, stick with we would basically choose the layered packages principle, not as a top level structuring mechanism, but as a mechanism to structure the code internally, then we unfortunately cannot make this class here package protected anymore, because it has to be visible for the inventory, right? So it's kind of that's not an option anymore. So the visibility modifier is not doesn't help us here anymore. So what we could use instead, and it's not the primary purpose. So I think I got ahead of myself a bit. The thing that you basically get with Spring Modulith is that you can actually create a runtime view or an application module view of your application programmatically, and I use this in my test case here, right? So I basically just create an application modules instance for my I pointed to my Spring Boot application, and that by default assumes that particular package structure that I have basically outlined you before, right? And there's a base package with the application, and then there's functional units as direct subpackages, right? So we would get that, and let's have a look at what this even what this prints. If we just like start this test here, execute that. Something's broken. That's fine. Let me quickly. We will go after that in a second. But the for each should work, and it should output something on the console. That's correct, right? So what it basically does is it inspects your code and finds the logical modules, right, in those packages basically, and also inspects the components, the Spring components that were exposed by the modules, and the relationships between those modules, right? And what the next, I mean, that's just like basically, okay, it makes up the module and basically has an understanding of your application. What was the next step here is that verify call is actually applying a couple of architectural rules out of the box that we kind of want to establish between the modules. One of them being there are no cyclic relationships between the modules. And the second one being that a module relationship, so a relationship from let's say here order to inventory, is only allowed via the module space package, right? And the inventory repository, do you remember that we've moved that into that internal package here? That's kind of the error that we just saw. And that's basically, you get this told here, right? The module order depends on a non-exposed type of inventory repository within module inventory. So what is established here is kind of by default and without having to do anything is a pattern that you saw in the OSGI world in like a couple of years ago, and you also see in the JPMS world, right? You have a base package that you expose, and everything underneath that is kind of considered private or module private, basically, right? So we basically compensate with that structure and with this approach for our lack of ability to use or to basically use the visibility modifiers. Bottom line and simplified, you have, let's say, an API package with your for each of your application modules, and everything else is internal. You can, of course, customize this by using annotations on, let's say, a package info Java to also expose that particular package. But by default, that's what you get, right? What you also get is, and that's basically the next step. Let me just remove that reference here again so that our test case is not failing anymore. Let me just like rerun it. So it's green again, right? So we basically detect architectural violations through the test case. And what we can also do, and already did, is we can actually visualize the module arrangement that we're kind of that we have created. The modularity test here is setting up a couple of options, right? So the canvas options, and it uses or pipes the modules instance into a documenter instance here, and it just basically says write documentation. And what that does is in the target folder of your application, it generates a Spring moduleth docs that contains like two kinds of files, and like, yeah, so one is UML diagrams for the module structure. Let me just quickly go here. This is basically what we have here. It's in a plant UML generated component diagram, and there's one created for like the entire arrangement and one for like the dependencies like between each module. So each module as a starting point, you see both the customer and the inventory module don't have any dependencies, and the order depends on both. So it's kind of like, okay, here's the order, or here's a particular module. What are the directly dependent on ones? The other stuff that you also get for free is this what we call module canvas, application module canvas, which lists the publicly exposed API and basically builds this up in a nice table here. So In this case, the inventory is, why is that public again? Let me just rerun it. It's still there, but it's kind of like it basically lists all the Spring components in here. It lists the configuration properties, right, that we have declared. Do you remember that configuration properties class with that stock threshold also evaluating some of the Java doc? And yeah, it basically gives you an overview about all the interesting parts of that module. Like everything that's kind of hidden inside the module is just not of interest in that case, right? It's not rendered here, so you get basically the starting points. If you can configure it to actually point to some URL where the Java doc is hosted for these classes, and then they would also create actually get some links attached here so that you can jump from the developer documentation to that stuff. All right. Let me briefly check in my demo notes here whether module integration tests. Good point. That's the final one for this section. We go ahead and we run integration tests. I mentioned that there is we can actually run like parts of the application in our tests, and that's achieved by this application module test annotation. And if you're familiar with the Spring Boot test annotations like add Spring Web or data JPA tests and whatnot, where we basically bootstrapped an horizontal layer of the application, what you get here is that we build up the module model and then just constrain the entire bootstrap to the vertical slice that we where is that? Is there some? Yeah, there's some log output. Let me just try to get this a bit smaller so that it reads nicer. You see here, we say application module test for the inventory, right? This module is bootstrapped. It's the same output you've seen before. And the important bit is actually here, right? So we constrain the auto configuration, entity scanning, and all that stuff to that particular module. In this case, it's pretty easy because like the inventory module doesn't depend on anything. With the order module, you remember the order management here, it had a dependency on some component within another module. And if we bootstrap only, in this case here, the order module, then there's not going to be a bean for that other module, for that component of the other module, right? So if we let me just try bootstrap in a failing way. If we run this will not going to start, because it basically says order management requires a bean of inventory, right? Which is not available because, as you can see in the logs here again, we are not. There is a direct dependency on the inventory module, but because we're running it in this default mode, it only bootstraps that particular module. So there's two options that we have. One is to actually mock the outgoing or the dependencies that we refer to, right? It's just an add mock bean annotation, standard Spring Boot annotation. So this will work again. The other thing that we could do, and this is where again the comparison to JPMS comes in, we can basically change the scope of the tests. Where we could basically say a bootstrap mode is, let's say, include all dependencies. That would, I mean, in this case, it's just like 2 or 3 tiny modules. But in a larger arrangement, that would basically select that individual module and will bootstrap all the downstream dependencies that are needed to actually bootstrap that particular subgraph of the module tree, and we'll just run that. So it would basically, in this case, include unresolved compilation problem. What's going on? Oh yeah, I have to, let me just skip this. I'm editing my code. But it will actually bootstrap fine, because in this case then, and the console will show this, it will not only bootstrap the order module, but it will bootstrap both the order and inventory module, right? So it will actually at test execution time, find out, okay, which stuff to include and basically run this. That's kind of the gist here. Let me undo everything that I've just done. And yeah, that's kind of the section on integration testing, right? And the integration test support. Are there any questions so far?
We
How
have
we
a couple
explain?
questions here.
Go ahead.
How easy would it be to deploy individual modules?
Excuse me, can you repeat at the beginning?
Yes. How easy would it be to deploy individual modules?
You wouldn't. That's the point. I mean, if you've decided that you want to build, let's say, a single Spring application or a monolithic Spring application, you could still have these individual modules, but you would always deploy them as a whole, right? We're currently investigating different areas that we could like advance our support in here. So we could, if we analyze, for example, the Git commits between, let's say, two commit hashes, we could find out that only code in a particular module was changed and then would only run, for example, the tests for that particular module to speed up the deployment process. But in the end, you would always deploy the thing as a cohesive unit. That's kind of the idea, right? If you don't want that, then you have to split up the system, or you could go ahead and basically use build modules and then have some assembly pipeline that would just like rebuild a particular module. But then again, you would have to assemble it and run it as a whole. But if you want to run and deploy it as like a module, as a canonical thing, then you would have to go and turn that into a separate like run deployable Spring Boot application or what have you. But even, let's say, if you started with this arrangement here, it's quite easy because like you kind of retain that modular structure of your Spring Boot application. It's much easier to, at some point when you decide, oh, I want to scale that particular part of my application separately, to pull out that package, put that into a separate Spring Boot application and run this and scale this separately if you actually need that, right? Whether that's the case is probably subject to your particular project, but we'd rather start simple here. And there's, of course, a couple of technical aspects that you cannot actually, or a couple of traits of a microservice architecture that you cannot get from this approach here, definitely. Yeah.
And are the architectural rules abstracted and cannot be overridden per developer needs?
Good point. So what's under the architectural rules is a project called ArcUnit, which you usually use to formulate the rules that you would want to imply on your architecture yourself. So you go ahead and write a test case that basically says, my package example.order establishes the order module, yada, yada, yada. So you basically have to do this yourself. What that part of Modulith or Spring Modulith is that you basically get these conventions that which can be tweaked with annotations. So you can basically define this package as a module package via an annotation, or this is not a module package via an annotation, all these kind of things. But you don't have to write these rules yourself. On the upside, another upside is that you get ArcUnit with your project. So if you have other, I mean, the rules that we apply by default are documented in the reference documentation. It's primarily cycle-free modules and API access to a module via its API package, and no field injection, a couple of like tiny Spring things that we usually recommend. But if you want to use or formulate further constraints on your architecture, then ArcUnit is already on your class path, so you could go ahead and basically write some yourself. I don't think we have already abstracted something where you can basically consume our definition of, let's say, you can refer to the order module as a logical module from an ArcUnit rule, but that would definitely, or is something that we definitely look into, and we're working very close with the ArcUnit developers on different features of that.
And what would be the scope of beans within the modules for references across modules?
The Spring app, so we're not doing anything with application contexts or application context hierarchies. And that's like one of the, let's say, the key design decisions we made early on. If you noticed, so far, except the package structure that we used, we haven't done anything to the actual application production code that is Spring Modulus specific. So it's a Spring Boot application. In other words, in production, Spring Modulus doesn't even have to be on the class path. So it's kind of like, as until now, we've only used it in the test, in test code and in the tests to verify the structure. There's no scoping going on. All we do is, like, for these integration tests, we basically exclude like certain packages from the component scanning, exactly as the data JPA tests, for example, do similar things, but let's say on a horizontal technical level. But no, we don't mess with any scopes or anything within the application context. It's all the same, basically.
What are the software tools or the integration development environment deployed for the project app demo?
You need to that for the demo. You basically just need a Maven, Java 17 installed, and then run Maven, the Maven wrapper here. It's a Maven-based project, and like whatever IDE you want to use.
Okay, and what are the development norms and standards for the program code of this app project demo?
What they are, or what was the question?
I'm reading the question verbatim. What are the development norms and standards for the program code of this app?
That's a broad question.
Demo.
It's basically the start, like this application, quote unquote, here focuses on showcasing the infrastructure, like the interaction, the definition of logical modules within a Spring Boot application, and the interaction between the two. We're going to go into event-based interaction in a second, but it's kind of, the package structure is what I'm kind of like playing with here and what I'm kind of suggesting. But other than that, don't feel like, okay, there's no real, or you should really do it like this in the code, right? I mean, I'm also doing nothing particularly simple here or trying to simplify stuff. It's just that I'm trying to just focus on the stuff that's important to this talk here. But yeah, so the structural arrangement, I think, is something that is worth studying. But other than that, yeah. All right, let me go ahead with the next step, actually, because
we'll have more time for questions at the end.
Yeah, sure. We'll have more time. So the next, or what we've seen so far, is that the order management. Whoa, what am I doing here? That the order management has, it actually has referred to the other Spring Bean, right, in the other modules. So there's been a cross-module relationship, and that is a bit problematic because I've been cheating here in the first place. Because if I were to update the inventory properly, I cannot just call an update stock method, right? I would have to basically hand in the order here, and that's problematic. I mean, I can, of course, I have to wait a sec. I have to update change the method signature, right? But that immediately causes a problem. Not necessarily in the test that there's some breakage here, I guess, because I just called the method. But even from an architectural standpoint, this is a problem because we now created a cyclic dependency between the modules, right? Order management knows about the inventory, and the inventory has to know about the order. So that's kind of a bit of a struggle here. We want to basically avoid that. The other thing is that, I mean, there's a transactional here, which actually basically is the same as defining it here. That method, that order completion, imposes a certain functional gravity because there's very likely there's other functionality to be attached to that business event completing an order. An email might have to be sent. We might have to update a rewards program or something like for the customers, what have you. Which means that with every other bit of functionality that we want to attach to that business event, we would have to create a new dependency here into some other module, and then we have to call a method on that, right? So we get some gravity here, and there's two ways to actually look at this. Like, one being, oh, that's just awesome, right? We can actually, to understand what's happening during a completion of an order, I just have to look at this method here. And then I find all the steps, all the things that happen on order completion. And even better, it's all transactional, right? So we have a consistent view on the world that way, right? So if the inventory update for some reason fails, it would just roll back the entire thing, and we have our system in consistent state. That's cool. I want that, right? That's kind of the way that Spring or the application developers usually use, let's say, the transaction annotation. There's another way to look at that, which is, oh, this is not a good idea, because that would mean that we can attach new functionality to that order completion at the risk of that new functionality, as trivial as it might be, might cause the entire application or the entire process to fail, because it would just roll back the entire thing, right? Do I want the addition of some bonus points in my rewards program to prevent, maybe because there's a bug in that, to prevent the completion of orders? Do we want that? The transactions in general should be kept small, right? If you've like been reading domain-driven design, it even says, okay, we can only expect strong consistency on the changes of a single aggregate. We're updating the stock here, we're updating the order here, so we actually like pull a lot of stuff into the transaction, which makes it bigger and bigger and bigger and bigger. And at some point, it might just like be scaling problems, or we basically make it more brittle because a lot of different stuff is happening here. Everything, or all these steps with a chance of breaking the entire thing. The other thing is that like adding more interaction to this point is complicating that method here, right? So we now, to test that properly, we now have to mock the inventory, we have to mock, let's say, an email sender, we have to mock a rewards program. Why would the team busy implementing the order management actually want to bother with that, right? So why we're kind of overloading that interaction here, or that event here with the interaction with all the different things. The order management all of a sudden is orchestrating all these things, and you could argue it shouldn't be that way, right? So let me just briefly go to one of the next steps. Check out steps. I think we want to go to step 2. Oh yeah, again. One sec. Here we go. So here is a way to actually change or to implement it in a slightly different way. Let me just refresh the. Where is it? Jesus, I'm getting this multi-monitor setup is not my strong suit. So I've changed the implementation here now. First, I mean, just to recap on the or to connect to what I've said previously, we now are back to using that single package module arrangement with package protected components that are not to be exposed. And also you can see that from the order management, the inventory is completely gone, right? Instead, we're doing something that we're using an event-based interaction mechanism. So there is an order completed event that's a record in here that just carries the order identifier that we register as event to be published when we call the order complete method. And this is what the order management is doing right here. It says order complete, and then you get a bit of event publication support from Spring Data. That's what we're using here to expose that event when we call save on the repository. So whenever we basically issue a state transition on the aggregate and we persist that, that's causing the event to be triggered. There's nothing specific to Spring Monolith at all. It's just a Spring Data functionality. We just use it in this case to simplify the event publication. And on the inventory side, we have an event handler registered that would basically listen to that event, and that could then basically trigger the functionality of updating the stock for that. And what we've achieved is that our architectural test is green again, right? So we've basically resolved the architectural cycle, and we've basically changed the arrangement from like one module calling the other actively through a Spring Bean component, with the module just publishing an event and the other module listening to it. And that fundamentally changes the way we actually think about, or can also think about, the testing. Because now all of a sudden, if you remember before, the order integration test had to refer to the inventory, right? So it had to consume the bean, which it doesn't have to now anymore, because it would just publish an event. And the testing is basically changing from, oh, let's complete the order and verify the inventory was called, to, oh, let's capture all the published events that happen through this text, while this test executes, and then have an assertion on the tests that were actually published, right? That's kind of, so we expect an order completed event to be one order completed event referring to that order with that given ID to be thrown, right? So the side effect of the execution of complete order kind of ends within the module. That's the crucial part here, right? And the other module would just react to that. And we're getting, through Spring Modulith, we're getting support for the testing and implementing the interaction of these things, right? All right, that's just basically a different kind of approach of interaction. Coming back to transactional event listeners and error scenarios. If you switch to that event-based mechanism, or the event-based interaction mechanism, then you will run into the problem that you will actually want to implement this interaction or the event listening in a transactional event listener. Let me give you a use case. If you have to send out, let's say, a confirming or final email of the order being completed, then you can't actually do that from within the transaction. So publishing the event and immediately handling it doesn't actually cut it, because the transaction is not like committed yet, right? So you would send out that email, and the transaction might potentially roll back. Spring has the notion of transactional event listeners for that, which allow you to actually get the event handled when the transaction commits, right? So it can be saved that the original transaction is has committed. There is a problem, though. Let me just unfold this, and we don't have to go through this in entire detail. Is that's just the way that the events are basically multicasted through a Spring application. Standard at event listener annotated events basically take part in the transaction, and they will be rolled back, or the state changes they actually implement will be rolled back when let's say the transaction rolls back. After the commit has happened, the transactional event listeners will be invoked, like sending out an email, right? Which just basically triggered after the event, the transaction was committed. And that bears the risk of, let's say, an event being lost, right? So if that event order completed is published, and we're not able to send out the email, let's say if that transactional event listener blows up because it cannot reach the SMTP server or something, it throws an exception, then that event is lost. The event publication is lost, right? And because like Spring Modulith actually incentivizes like the cross-module interaction with event listeners in general and transactional event listeners in particular, we have to find a solution to actually to avoid these event publication losses, basically. And what Spring Modulith includes is a so-called event publication registry, with the idea being the following. Let's say if we publish an event, Spring knows about all the transactional event listeners that are in place in the application. We can actually write within the very same transaction, we can actually write entries, these blue bubbles here, basically taking a note that this transactional event listener has to be invoked, right? There's got to be an event published to it, and then when the transaction actually commits, we publish the event to these transactional event listeners. And for the ones that succeed, we basically scratch that entry in the event publication log. And for the ones that fail, we keep it around, right? And that allows us to, like after publication, like on a continuous basis, we can actually resubmit the events in case they failed. So take a different scenario, the application goes down because someone basically pulled the plug during transaction event listener execution. On application startup, we would still find these entries for, oh, the order completed event still has to be published to the email sending event listener. And it would basically do that. So I guess I skipped the demo for that because we're like a bit running out of time. And I would like to show you, I mean, if there's a question for that, I would basically take the chance or the time to, let me just go ahead. If I take,
Ollie,
prepare the.
I'll tell you what we'll do. Our official ending time is 5 minutes from now, but we can keep going for a little while if it's okay with you. And
That's
what
fine.
I'll do is ask the questions that have been posted since the last break after you've finished.
Okay. We can do that.
Yeah, and for those of you who are watching, we're in the middle of the J Champions Conference. The official end of this session and beginning of the next session will be in about, well, now 4 minutes, but we can hang on here for a while and see a little bit more of the presentation from Ollie and also take your questions. It'll overlap with the next session, but hey, that's life, right? Yep. Okay, go ahead.
I hurry.
You don't need to. You don't need to. Okay.
So what I've done here is the example. Basically, I think it's the third step. The step 3 called event publication registry basically contains some code that shows how this stuff works. So on the order complete call, we issue that order completed event, and I'm registering a so-called application module listener. That's just a shortcut for transactional event listener and an asynchronously invoked transactional event listener. And I let that fail, right? And what you see when you execute that, we basically wait for a couple of milliseconds and then use the event publication registry to inspect it for incomplete publications. That's totally not something you would do. It's just for demo like in a normal test or what have you. It's just for demo purposes. And you would see here that there is like the order is basically inserted, and in this case there's an event publication registered in the database as well. And then we find that particular transactional event listener failing that's logged at info level, because that's we try to complete, try to wipe out the publication, but for that we need the listener to succeed, which it doesn't. And that actually means that single publication is still alive, which also you can see here in the log output. When the application shuts down, it basically just writes out, okay, there's a couple of events that we haven't processed properly, but that are still around. And if I hadn't been using an in-memory database, they would have been like around for with the next application startup. That's kind of the idea. All right. The final thing I would like to show, and I've just added that like this afternoon, is that so far we've used the event publication registry is already runtime support for the application, but there also is the primary functionality is all like just test code scoped, basically, right? You run the verifications during the test, you run integration tests. It's already very focused on the tests. What we can still do is we can expose that modular information, that architectural information that we've also basically written out into the reference documentation. We can also expose that at runtime, and I've done so by adding a particular profile to my application that includes a couple of new dependencies, like the Spring Boot starter actuator and the Modulith actuator. And if I activate that profile, I think I'm not even sure, it could be already, yeah, it's already activated. I run this application just as a standard application, like a standard Spring Boot application, run as Spring Boot app. We can switch to the browser and go ahead to localhost 8080. And it reacts, but it should the actuator endpoint now. It's like if you've been familiar with Spring Boot actuators, they give you this HTTP resources that give you insight into, let's say, the application's health and whatnot, right? So let's say a deployment platform would use it to inspect the application status and what have you. And that also basically exposes this application modules actuator now that renders a JSON structure for the dependencies between the individual modules. So you would be able to, let's say, your deployment infrastructure to find out about the structure of your application and then give you means to actually, like, let's say, set log levels per application module or what have you, right? So you could take this information forward. So you, as a developer, you arrange your code in a particular way, and that gets kind of basically derived into the reference documentation. It leaks into your tests. It kind of can be inspected at runtime, all these kind of things. So you can have, with a very local decision, a very local design decision, you can actually have effect into like different parts of your application's context, lifecycle, and what have you. So with that, just to recap, right? We have a convention to map these application modules to packages. We have verification of the structure so that we don't get our application to deteriorate over its lifetime. We can integration test individual modules or modules combined dynamically. We can expose the structure and that information in reference documentation, so ASCII doctor files generated, plant UML files generated. It's the term I try to coin here is the architectural observability. So at any time in your lifecycle, in your application, you have up-to-date architectural information and architectural documentation, and you always know what's the current structure of my system. There's no like outdated documentation or what have you. You deal with the code, and the code is architecturally evident, and you make use of that. And I didn't even mention the observability support here, if you find stuff in the reference documentation. So there's also runtime support for basically exposing the interactions of the individual modules to, let's say, a Zipkin or what have you. That's kind of, that's what happens. And with that, I'm happy to take the final round of questions, Barry.
All right. I hope you're ready for quite a few questions here.
Oh, wow.
That's good. It means it's a stimulating talk.
Yeah, sure.
Yeah. Some of them are nuts and bolts questions. I'm going to try to get to all of them. Let me know if we've run out of time on your part. I have time. It's fine. Okay. All right. Here we go. And I figured out how to do this in a nice, clean, easy way. Why is it better to have an internal package instead of package private classes?
I didn't want to express any preference for the arrangements. If in doubt, I would start with, that's just the package private classes, package private types, and whatnot. If your module grows quite a bit, then it might just be reasonable to basically have an module internal structure. And I wasn't suggesting to name a package internal, right? There could be some internal structure that you express via, let's say, sub packages. And if you do that, then, or the point I was trying to make is, if you do that, even if you do that, you're not losing the functionality of that kind of preventing access to the internals, right? That's been the idea. Another factor often is that a module might not have a single quote unquote interface into it. So there might be an API, but also some kind of extension API or some extension SPI of a module, where you say have a customization interface or something like that. And you could easily just pull that into a separate interface and then I didn't even mention that. Like all the module relationships that were verified in my example were totally implicit, right? We were just making up the dependencies as we went. And the verification only struck us once we've basically reached out to an internal or created a cyclic relationship. But you also have the ability to explicitly define what particular module another module is allowed to depend on. You could say module A is only allowed to depend on module B, and they would implicitly be not allowed to depend on module C. And those named interfaces, as we call them, can be part of such declaration. So you can say a module is only allowed to depend on this particular named interface of that module. So you can be very explicit about this arrangement, exposing it, and also explicit about the arrangement depending on it. That's the idea here. And in that case, you would be very likely to use any packages or what have you. Or if you just want to follow, let's say, hexagonal architecture within your module, then you usually create these packages. And that's it. There's no preference in here. It's also supported.
Okay. How did you proceed in order to import and integrate the Maven tool to synchronize it with the Java IDE?
I don't really get it. I mean, I'm using Eclipse here, which probably makes me an old fart. But it's just like the Maven support is built in with that. And what I'm doing, I've just on the command line basically switched to different tags in my GitHub source tree, and then I refreshed the project basically. But other than that, nothing fancy.
Okay. Can the event registry be integrated easily with something like Kafka?
Very good question, Joaquin. Right now we have support for the event registry that the primary integration mechanism is via the persistence mechanism in the first place, because we have to basically attach to a persistent store that supports transactions. So currently we support the JPA out of the box, everything that's JDBC, and the MongoDB if you use it with transactions. What we haven't done so far, but what we're definitely looking into, is that for a particular set of events, you might want to decide, oh, these are not only interesting for our internal components, but they also might be interesting for, let's say, other systems. And we're looking into options to make it easy to basically simply say, okay, this event is something, externalize this event, and then have some means to define like which Kafka topics they actually supposed to be published to. But there hasn't been any like detailed investigation in that yet. If you want to create a ticket and basically drive that discussion forward, it's definitely something that we have on the roadmap or on the radar to see that. But yeah, it's not that far grown yet.
And fault tolerant event listeners architecture in a way related to Saga execution pattern?
I'm trying to grasp the actual question here. So right now, what the primary focus of the event publication registry is not losing these events, right? So the transactional event listeners still have to be written in an idempotent ways, because you might see an event multiple times. So it's at least once delivery here, and it's only within the system. So we're not kind of focused on, let's say, orchestrating a lot of like functionality across multiple modules. That's not like, we're not just like in the business of that yet, right? And we also would like to keep that functionality like focused on a particular aspect for now. So there's no dedicated support for anything Saga or coordinating or anything Camunda like BPMN-ish. Nothing there yet. Yeah.
Okay, and we have a comment here, and the question is my assumption correct? So here's the assumption. If we use the event approach, it means the producer module will be the source of the truth of the information, and the consumer module will have a projection of the data in its own database model.
That's definitely a way that you can skin the cat here. There's a couple of aspects, like fundamental aspects that basically come out of the question. First thing is that these events being published become part of the module's API, right? Although they're not a Spring component or what have you, they are part of the API. They're part of the provided functionality, quote unquote, and the documentation, the application module canvas that I showed you will actually document all the events that are published for each module, and it will also find out about all the events that are listened to by a particular module. So you can that interaction becomes somehow visible. And that also means that a listening module is kind of depending on the structure of these events, on the types. And actually, I mean, we're kind of leveraging the fact that we're part of a kind of the same compile scope here, and the fact that we could even go ahead and basically refactor such an event. And it would immediately, if we use our IDE, we can immediately see the effects in the other modules, and we could basically adapt in the other modules for the same commit, for example, for the same change, and then roll this change out as a whole. That's kind of a benefit of this. We ship this thing as a canonical thing, right? Whereas in a distributed environment, you kind of have to, we can only change it in a backwards compatible way, or we kind of have to deploy this first and then adapt to that later. So it's a bit of a more complicated scenario if you're in a distributed environment. Whatever the actual module then does with the data structure is up to the module, right? I guess you would definitely want to, let's say, if you want to, let's say, just keep like certain attributes of an event being published, then I definitely copy them into my own data structure and then basically persist that rather than relying on the API of that event type for more than just immediately pulling out the data. But that's basically design space to be explored here. Also, the question: do I include much data into the event, or do I just include references? Kind of depends on the use case. But for us, the primary focus was to, okay, we've learned that events are a good means of communication between like distributed systems and allow them to decouple them to some way. Let's have a look at how we can make this easy for, let's say, in-process communication, right? Just between logical modules. You can have the same approach, basically. Yeah.
Hey, wow, this has been great. Ollie, thank you so much. How long did you, was it an hour before this talk started that you volunteered to do it?
I mean, I've given the talk before. I mean, I guess you.
No, don't tell them that. It was about an hour before. Jumping
in
for Andrew Greenstein.
And I guess you could feel at some point that I was kind of like, where was I going with this time?
Anyway, thanks so much for filling in. It's been a great session. And if you're for those of you who are watching this on YouTube, if you're watching it live, please, we've got another half day today. We've got another 3 days of the J Conference, J Champions Conference tomorrow, and then in the beginning of next week. Please join us. If you're watching this after the fact on YouTube, look over all the sessions and check them out, and watch what you can. This is all going to be great stuff. Thank you so much, Oliver. We'll see you again soon.
Take care. Thank you. Bye-bye.